April 10, 2019. 6 cities: Washington, Brussels, Tokyo, Santiago, Taipei, Shanghai. At the same hour, screens light up with one image. It is orange, blurred, ringed in shadow. It is the first photograph of a black hole. Getting there took over a decade. In 2006, a young astronomer named Shepard Deuleman began asking a question nobody could answer. Could a network of radio telescopes scattered across the planet work as one single instrument the size of Earth? The target was M87, a galaxy 55 million light-years away, and the supermassive black hole at its center. A black hole itself emits no light. What the team wanted was its shadow, cast against the glowing gas that swirls around it. By 2009, 8 observatories on 4 continents joined the effort. It became known as the Event Horizon Telescope. Each site pointed at the same patch of sky on the same nights, using atomic clocks accurate to 1 second in 100 million years. Because without that precision, the signals could never be lined up later. In April 2017, the network ran for 10 days straight. Weather had to cooperate at every site at once, from Hawaii to the South Pole. It rarely does. That year it did. The telescopes did not capture a picture. They recorded raw data, 5 petabytes of it, too much to send over the internet. Hard drives were flown by plane to 2 processing centers, one in Massachusetts, one in Germany. Then the real work began. A graduate student named Katie Booman had spent 3 years building algorithms to turn fragments of radio data into a coherent image without letting any single assumption bias the result. 4 separate teams worked in isolation from each other, each blind to the other's methods. The reasoning was simple. If 4 independent approaches produced the same shape, the shape was real. For months, none of them were allowed to compare notes. Then, in the summer of 2018, they opened their results at the same time. 4 blurred rings, nearly identical. The fear had been a trick of the algorithm, a shape invented by the software instead of the sky. Instead, the universe agreed with itself 4 times over. The image showed a bright, uneven ring of glowing gas, bent by gravity so strong that light itself curved around the darkness at its center. The dark region measured about 40 billion kilometers across. The black hole itself carries a mass of 6.5 billion suns. On April 10, 2019, the Event Horizon Telescope collaboration, over 200 scientists across 20 countries, released the image to the public. Katie Booman's algorithm sat quietly at the center of the result, but the credit was never meant for one person. It took 8 telescopes, 60 institutions, and 2 centuries of physics that began with a letter Einstein once doubted himself. In 1915, general relativity had predicted objects so dense that not even light could escape them. Einstein calculated the mathematics, but questioned whether nature would ever produce something so extreme. For over 100 years, the black hole existed only on paper, a solution to an equation, argued over by physicists who had never seen one and assumed they never would. The 2019 image changed that. It did not just confirm a black hole existed. It confirmed the exact shape general relativity predicted down to the curve of the light. In 2022, the same collaboration released a second image. This time, the target was closer to home. Sagittarius A star, the black hole at the center of our own galaxy, 27,000 light-years away. The team is now working on something no single image can capture. A movie, tracking the shifting glow of gas as it spirals toward the edge of the darkness itself. If it works, humanity will not just see a black hole, it will watch one breathe. The footage does not exist yet,